Welcome to Learning AI Today. In today's explainer, we're tackling a massive question: RAG versus fine-tuning. Which one does your AI actually need? Look, imagine you build an AI chatbot for your company. You hook it up, it sounds incredibly smart, and your team absolutely loves it. But then a customer asks it about your return policy, and it confidently spits out completely wrong information. The customer follows that advice, things go sideways, and boom, trust is instantly broken. That right there is the nightmare scenario. You get a hallucinated answer wrapped in absolute confidence. Contrast that with a grounded, factual answer that actually gives a correct, traceable citation. Now, both of these outputs might use the exact same foundational model under the hood, but the architecture behind them is completely different. To get that factual, grounded result, you generally have two paths: RAG or fine-tuning. And honestly, picking the wrong one right out of the gate is going to cost you serious time, money, and credibility.
But before we can fix it, we have to clearly define the enemy here: hallucination. It's when an AI produces a confident but entirely false or fabricated response simply because it's not grounded in its actual training or your provided data. Make no mistake, this right here is the absolute #1 reason AI projects fail in production today.
So here is our roadmap for today's explainer. We'll start with the shared problem, dive into how RAG works, break down fine-tuning, put them in a head-to-head comparison, give you a solid decision framework, and finally look at the essential AI tools you need to build this stuff. All right, section 1, the shared problem.
Think of a base large language model like a brilliant, highly educated brain, but it's completely locked in a room. Now, these models are trained on massive data sets, taking months and costing literally millions of dollars. But the second that training ends, their knowledge is completely frozen. They hit a hard cutoff date. So they know a ton about the world broadly, but they have zero window to the outside world. They know absolutely nothing about your private company data, your internal wikis, or the products you launched yesterday.
Section 2, RAG explained. So how do we get data into that locked room? RAG. It stands for Retrieval Augmented Generation. Meta researchers actually officially introduced this whole concept in a landmark paper back in 2020. The easiest way to think about it is like this. A standard model is a student taking a closed book exam. They just have to guess based on what they've memorized. RAG basically turns it into an open book exam. The AI is actually allowed to go search for the answers in real time before it even generates a response. Here is how that plays out step by step. First, you take your private documents. Second, they go through an embedding process, which is basically just turning your text into numbers, or vectors. Third, those numbers get stored in a vector database. Fourth, when a user asks a question, the system does a retrieval step to pull the most relevant document chunks based on their meaning. And finally, step 5, those specific chunks are fed right into the prompt so the AI can generate a grounded answer. It's not guessing, it's literally reading your policy right before it speaks to the customer. Okay, so why does this matter so much? Well, the numbers for 2026 are just wild. A well-optimized RAG setup can trigger an incredible 70% cost reduction in monthly AI operations compared to heavy infrastructure alternatives. But more importantly, in the real world, hallucination rates drop from around 15% down to below 3%. And honestly, the best part? You can update your knowledge in real time. You just drop a new PDF into your database and boom, the AI knows it. No expensive model retraining required whatsoever. Let's move to section 3, fine-tuning explained. So if RAG is giving the AI a book, what is fine-tuning? Well, a base model is kind of like a general doctor. They've got broad, solid, baseline medical knowledge. But a fine-tuned model, that's your specialist surgeon. I mean, they both went to the exact same medical school initially, but the surgeon went through additional intense training on a very focused data set. Fine-tuning actually alters the model's internal weights, its behavior, and its vocabulary to give it deep, highly specific domain expertise. Now, it used to be that fine-tuning was incredibly expensive because you had to retrain the entire massive model. But today, we use things like LoRA, that's low-rank adaptation. With LoRA, we actually keep that giant base model completely frozen, and we only inject and train these tiny, specialized adapter matrices at specific layers. It carefully guides the model's behavior without having to completely rewrite its entire brain.
And the financial impact of this is just staggering. Not too long ago, doing a full fine-tune of a 7 billion parameter model would easily require $50,000 in high-end H100 GPUs. Today, using techniques like QLoRA, you can fine-tune that exact same massive model on a $1,500 consumer RTX 4090 graphics card. It is a total game changer that has completely democratized specialized AI.
All right, Section 4, the head-to-head comparison. So how do they actually stack up against each other? Well, RAG absolutely wins when you need current facts and private docs. Fine-tuning, on the other hand, wins on teaching the AI specific behaviors, styles, and tones. For setup cost, RAG is pretty low. We're talking hours. Fine-tuning is medium to high, usually taking a few days. Training data? You don't need any for RAG. Fine-tuning needs anywhere from 500 to tens of thousands of examples. When it comes to hallucination risk, RAG is low because it's grounded directly in your docs. Fine-tuning is still medium risk because it doesn't have live data access. For knowledge updates, RAG is instant and real-time, whereas fine-tuning requires a full retrain to learn a single new fact. Latency is where fine-tuning gets the win because the knowledge is already baked right in, avoiding that extra retrieval step. And finally, explainability. RAG is highly explainable because it literally cites its sources. Fine-tuning, it's much more of a low explainability black box. And as the recent LoRA benchmark from 2025 showed us, there is simply no single silver bullet here. It completely depends on what your system actually needs to prioritize. Which brings us to Section 5, the decision framework. To figure out exactly what you need, let's walk through 3 key questions. Question 1, is your knowledge changing frequently? Think about retail FAQs or internal corporate wikis. If your data is updating constantly, RAG is your absolute necessary choice. You just cannot be retraining a model every single time your shipping policy changes. Question 2, is hallucination dangerous in your use case? Say you're building an explainer for a healthcare decision tool or you're analyzing legal contracts. You absolutely need traceable citations. In those high-risk environments, RAG is essential because you can verify exactly where the AI got its answer. Question 3, do you need consistent behavior, format, or tone across all of your outputs? Let's say your AI always needs to output a very specific JSON structure or write in a super rigid corporate brand voice. Look, standard prompting will eventually drift under pressure. It just happens. If you need strict output formats, fine-tuning is practically required to lock that specific behavior in. Section 6, essential AI tools. If you're building a RAG pipeline, you're definitely going to be looking at these tools. Pinecone is the go-to managed vector database right now. It saves you from massive infrastructure headaches. And LangChain has really become the industry standard framework for stitching together the whole document loading, chunking, and retrieval pipeline. Now, if you're going the fine-tuning route, Hugging Face is going to be your starting point. It gives you access to well over 1 million open-source models. And then, when you need to run enterprise-grade fine-tuning operations reliably and at scale, Amazon SageMaker is the heavyweight platform of choice. But here is what you really need to take away from all of this. The ultimate 2026 production standard isn't picking just one. It's using both. You fine-tune for behavioral consistency, and then you layer RAG right on top of it for real-time factual grounding. Next week, we're actually going to build this exact hybrid architecture live using Anthropic's Claude, so make sure you're subscribed for that. As you map out the architecture for your next big AI project, ask yourself, are you building a system that merely sounds confident or a system that is actually correct? I'll leave you with this final rule of thumb. RAG keeps your system truthful today. Fine-tuning makes it consistent tomorrow.